Hello, you are welcome. The question here says a stone is thrown upwards with a velocity of 60 meters per second at an angle of 30 degrees to the horizontal. Calculate its vertical velocity after 1.5 seconds, its vertical height at this time, its horizontal distance at this time, and finally, its horizontal velocity at this time. And we are given acceleration due to gravity as 10 meters per second square. Now, for us to solve this, let's first of all write down the quantities that were given, the parameters that were given in the question. Now, the question here says a velocity, that is the initial velocity, is given letter U. U is the initial velocity, and that is equal to 60 meters per second. And then going further, we are told that the angle of projection, that is the angle at which it is thrown, is 30 degrees to the horizontal. So that angle is theta. So theta is equal to 30 degrees. And then the next thing we are given is, from the first question, we are given the time, t, as 1.5 seconds. So I'm going to write that down as t is equal to 1.5 seconds. And then let's not forget the value of g as 10 meters per second square. So g is equal to 10 meters per second square. And then the first question here says we should find its vertical velocity. So vertical velocity, we can write that as v subscript y. Y for vertical axis, so the v for final velocity, and that is what we are asked to look for. Now, the first thing we can do here is to straight away apply the formula for vertical velocity so that we can get that straight. So the formula for vertical velocity is given as v subscript y is equal to u sine theta minus gt. Now, don't forget that this equation is similar to the equation of motion, which is v is equals to u minus gt. But because we are given the projection at an angle, so it must be the vertical component of the velocity that must be used in this case. And so the vertical component has to be u sine theta. So that is what will affect this vertical motion. So this sine theta must be added to the value of u to give us the vertical component of the velocity. Please don't forget that. So when you have problems like this under motion where you are given at a particular angle, please, with respect to the velocity, add the sine theta, and sometimes it might be cos theta, as the case may be. As we go on, we'll see that. So this is the formula to get the vertical velocity. Now I can go on and substitute values. So the value of u is 60 times sine, the angle is 30 degrees. So I can put this part in bracket, minus g is 10. The value of g is 10, as you can see here. 10 multiplied by the time is 1.5. 1.5. So from here now, we can go further and find this vertical velocity. Sine 30 is 0.5. So I can simply say 60 times 0.5, then minus 10 times 1.5 will give us 15. So 60 times 0.5 is simply 30. So we say 30 minus 15. And that will give us the vertical velocity as 15 meters per second. So this is the answer for the vertical velocity. So I hope you got that right, or I hope you got that explanation. Now let's move to the second part of the question, and that is the B part of the question. Now the B part of the question says that we should calculate its vertical height at this time. So we have to calculate vertical height in this question. And for us to calculate the vertical height, we can also apply the formula that will help us get vertical height directly. And so I'll simply say the vertical height square, that's the formula to apply now, is u sine theta all squared minus 2gh. So this is the formula to apply to get the vertical height, h. Don't forget this v subscript, right? Don't forget this equation is not really strange to us. It's similar to the equation that says v square is equals to u square minus 2gh. So what we just need to do there is, like I told you before, the u, don't just use the value of u, always use the vertical component of u, which is u sine theta. So we take u sine theta and then we square it, and then minus 2gh. So all these equations are the original equations of motion, but just a little adjustment because of the angle that we have in the question. So v square, now don't forget our v is 15. So I'm simply going to say 15 square is equal to u, which is 60. Don't forget the value of u is 60 in the question. So I say 60 times sine 30, which is the angle, all squared minus 2 times 10 times h. Don't forget we are looking for the value of the height h, the vertical height. So this will give us 225. 15 square is equal to 60 times 0.5 all squared minus 20h. So when we simplify this further, we are going to get 225 is equal to, now if you look at this clearly, you observe that 60 multiplied by 0.5 will give us 30. So I'm going to say 30 square minus 20h. So what I can do next now is to carry this negative 20h to this left hand side so that it becomes positive. When this negative 20h comes to this side, it becomes positive 20h. And is equal to 30 square is 900. Then minus 225. When this positive 225 comes to this side, it becomes minus 225, becomes minus negative. And so we can go on here and simplify further as 20h is equal to 900 minus 225 will give us 675. 675. And then I cannot divide both sides by 20. I divide this by 20. And that will give me the value of the vertical height, because this 20 we cancel 20. And I have h is equal to 675 divided by 20 will give me 33.75. 33.75 meter. So this is the vertical height in the question. So that is question B solved. Now let's move to question C and see what the question is asking us. So the C question here is saying that we should calculate each horizontal distance at this time. So we have to calculate the horizontal distance. Now, in calculating horizontal distance, we are no longer going to use the vertical component of the velocity. This time we'll use the horizontal component of the velocity. And you agree with now, horizontal component is u cos theta, not u sin theta. U sin theta is for vertical component of a vector, while u cos theta is for horizontal component of a vector. So I can go on and say question C, to get the horizontal distance, I simply use the formula that S is equal to ut cos theta. This is similar to the equation that says S cos to ut. But in place of u now, we're going to use the horizontal component of the velocity, and that is u cos theta. So it is u cos theta that gave us the horizontal component, and then we'll simply multiply by time. So this will now simplify to the value of u, which is 60, multiplied by the time is 1.5, because we are told that it is at this time 1.5, and then multiply by cos 30 degree, that is, the angle is 30. So simplifying this further, we have 60 multiplied by 1.5 times 0.866. The value of cos 30 is 0.866. And by the time we multiply these values with our calculator, it's going to give us that horizontal distance as 77.94 meters. So this is the horizontal distance. So take note of that. And then let's look at the last question now. That is the D part of the question. So the question D says we should find each horizontal velocity at this time. The horizontal velocity is what we are to look for at this time. So I'm simply going to solve that horizontal velocity with a direct formula. So let me just rule a line here so that I can solve it here. So the horizontal velocity here, we'll use the formula that says that the Vx now, don't forget, horizontal velocity is Vx, vertical is Vy. So horizontal velocity is Vx is equals to u cos theta. Now don't forget that this horizontal velocity is constant throughout the motion. It is not affected by acceleration due to gravity. So it is a constant value throughout the motion. At any point in the motion, whether at any time in the motion, this is always the horizontal velocity, is a constant value. You don't use time or you don't use g to calculate this. Take note of that. So u is 60 and then multiply by cos 30. The value of the cosine of 30 is 0.866. So by the time we multiply 60 by 0.866, it's going to give us 51.96. 51.96 meter per second as the horizontal velocity of the motion. Hope you enjoyed this video. Please don't forget to like and share this video so that others can learn from it. And don't forget to join me in my next video. Thank you for watching.